We have a region bounded by these two graphs, and we want to revolve this bounded region about the vertical line x equal to 6. So this graph is the graph for f of x equal to 6x minus x squared, and this is the graph for y equal to 0 or g of x equal to 0, and this is the vertical line, the axis of revolution, the vertical line x equal to 6. So we'll take this region right here, bounded region, and we'll rotate it around this vertical line, and then get the solid of revolution. So first, since the axis of revolution is vertical, we'll fill the bounded region with vertical rectangles. And then we'll rotate each rectangle around the axis of revolution, and we'll get shells. And we'll find the volumes of all the shells, add them up, and that will give us the volume of the solid of revolution. Now for this rectangle, this is what the shell looks like. Since we're taking this rectangle right here and rotate it around and revolve it around the axis of revolution, this line right here, and we'll get this shell. And so to get the volume of the solid of revolution, we need to figure out what the radius and the height of the shell is. For this particular example, the axis of revolution is not the y-axis, and therefore the average radius will not be x. And so this is the middle of the shell is right here. So the distance from the y-axis to the middle of the shell is x. The distance from here to here is 6. But our radius this time is from here to here. Is from the axis of revolution to the center of the shell. So from here to here is x, from here to here is 6, and so the radius will be 6 minus x. And so again, from here to here, from the y-axis to the center of the shell is a distance of x. From here to here is a distance of 6. And our radius, our average radius is from here to here. So this distance right here will be 6 minus x. And so the average radius will be 6 minus x. The height of the shell will be just the f of x minus g of x. So it's going to be 6, the top graph here is 6x minus x squared. And the bottom graph is the g graph, which is y equal to 0. So we have 6x minus x squared minus 0, which is 6x minus x squared. And so one more time, the average radius is 6 minus x, and the height is 6x minus x squared. And x ranges from 0 to 6, or the shaded region, the bounded region. X ranges from 0 to 6. So our limits of integration will be from 0 to 6. So we have the average radius is 6 minus x. The height is 6x minus x squared. The thickness of the shell is represented by dx. Multiply this out, we get 36x minus 6x squared minus 6x squared plus x to the third. Minus 6x squared minus 6x squared is minus 12x squared. Antiderivative for x is x squared divided by 2. Antiderivative for x squared is x to the third divided by 3. Antiderivative for x to the third is x to the fourth divided by 4. 36 divided by 2 is 18. 12 divided by 3 is 4, and this is 1/4. And we'll evaluate from 0 to 6. And then so we'll plug in 6. So we have 6 here, we have a 6 here, and then a 6 here. And the lower limit of integration is 0, so we're plugged in 0, 0, 0. And then simplify all of this will come out to be 216 pi. So the volume of the solid of revolution will be 216 pi.